In this video, I will continue section 3.4 on partial fractions, but this time I will do an example with 3 distinct linear factors. So remember from the last video that when we have 3 factors, this is pretty much what we're going to do. We're going to start with an integrand, right? The function that we're integrating is going to look like this, like a rational function. And we're going to factor the denominator, but this time the only difference is that we're going to factor it into 3 terms, and then we're going to have to find 3 unknowns, capital A, capital B, and capital C, instead of just 2. So let's do an example. So the process is the same. The only difference is that we're going to have 3 terms now instead of 2. And so we have 3x plus 2 over x cubed minus x squared minus 2x dx, right? So remember, the first thing we want to do is go from here, what we're given, to a factored denominator. So the first step is to factor the denominator. So I'm going to take my denominator, x cubed minus x squared minus 2x. And the first thing you should notice is that all of the terms have an x in them. So we can factor out an x out of all of the terms. And then we can factor x squared minus x minus 2, which, right, what multiplies to -2 and adds to -1, right? We're going to have 1 times -2. So this is going to become x times x plus 1 times x minus 2. All right, so this is our factored form. So right now our integral, right, we went from 3x plus 2 over x cubed minus x squared minus 2x dx, and now we have 3x plus 2 all over x times x plus 1 times x minus 2. Right, and so now, right, our goal is to go from this middle stage where we're at with a factored denominator to breaking it up into 3 different factors. And so what we do is we take 3x plus 2 all over x times x plus 1 times x minus 2. And we want to find a capital A, a capital B, and a capital C where these 2 things are equal to each other. Right? So the first thing that we do, we want to get the A, B, and C down. That's what we're trying to solve for. So we'll multiply both sides by x times x plus 1 times x minus 2. Right, and automatically that's going to cancel out this denominator. So on the left-hand side, we're just left with 3x plus 2. Right, and then on the first term, the x is going to cancel out the x. So what we're left with in the first term is going to be a times x plus 1 times x minus 2. Right, and then in the second term, when we multiply by this, right, the x plus 1 in here is going to cancel out with this x plus 1. So all we're left with on this term is the b and the x and the x minus 2. Right, and in the third term, the x minus 2 in the denominator will cancel out the x minus 2 in what we multiply by. So all that's left with on that term is x and x plus 1. Right, so then what we did, right, our strategy is let's plug in different x values so we can eliminate some of these unknown values and at least solve for one unknown. So the first x that we'll plug in, right, if we plug in x is 0, then this term and this term, right, anything times 0 is 0, so both of these terms will become 0, and we can solve for a, right? So let's let x be 0. So that becomes 3 times 0 plus 2 is a times 0 plus 1 times 0 minus 2 plus b times 0 times 0 minus 2 plus c times 0 times 0 plus 1. So both of these terms are 0. So this becomes 2 is equals to a times 1 times negative 2. So that's just going to be negative 2a. And then when I divide by negative 2, I'll get a is negative 1. So now our equation becomes 3x plus 2 is, right, negative 1 times x plus 1, x minus 2 plus b x minus 2 plus c x plus 1. Right, so now we can plug in another constant to either cancel out the b or the c. So how about we plug in x is 2, because that'll make this go to 0, right? So then let's do that. X is 2. So that's going to become 3 times 2 plus 2 is negative 1 times 2 plus 1 times 2 minus 2 plus b times 2 times 2 minus 2 plus c times 2 times 2 plus 1. Right, and we know when we have 2 minus 2, that's 0. So both of these terms are going to become 0. So I have 3 times 2 is 6 plus 2 is 8 is c times 2 times 3 is 6c. So that's c is 8 over 6 when I divide both sides by 6, and I can reduce that to 4/3. So that's our c. And last but not least, we can solve for b, right? So if we want to solve for c, right, what we should do is let x equals negative 1. So that's the only factor that I have not plugged in yet. So this is our final factor. So 3 times negative 1 plus 2 is equals to negative 1, negative 1 plus 1, negative 1 plus minus 2. Plus b we haven't solved for. So that's negative 1, negative 1 minus 2, plus c we solved for was 4/3, negative 1 times negative 1 plus 1. So both of these negative 1 plus 1, right, is 0. So that makes the whole term 0, which is what we wanted. So this is negative 3 plus 2, which is just negative 1. And then we have negative 1 minus 2, that's negative 3, but times negative 1, that becomes a positive 3. And then if I divide both sides by 3, I'll get that b is negative 1/3. Right, so recall what we had was our equation set up like this. Alright, so now we know a, b, and c, so we can set up our integral using a, b, and c. So remember, our integral up to this point was this right here. So now we're going to rewrite that as the integral. Capital A was what? Negative 1 over x, plus b was negative 1/3 over x plus 1, right? So I'm plugging into this form here. And then c was 4/3, and that was over x minus 2. Right, so we can see this as 3 separate integrals, right? We can do the integral of -1 over x dx plus the integral of -1/3 over x plus 1 dx plus the integral of 4/3 over x minus 2 dx. Right, and now I can pull out constant multiples, so I can simplify the numerator on all of these fractions by just pulling out the constant that it's being multiplied by. So then I pull out the 4/3, and then, right, so your integral at the end is always going to be a similar flavor, because that's literally how we're setting up these factors, right? Like your integral is always going to look like this, so you always know it's going to be a u sub with the ln functions, right? Just like we saw in the last example. So this one, we know the antiderivative of 1 over x is simply ln of the absolute value of x plus -1/3, and then for these ones, we know we technically need to do a u substitution, right, where u is x plus 1 in this one. Derivative of x is just 1, derivative of 1 is 0, so this is just dx. Right, in here we let u is x minus 2, and again du, the derivative of x minus 2 is just 1, so it's just dx. So then that becomes, right, this becomes the integral of 1 over u du, and the integral of 1 over u du. So then, right, we end up with ln of u, right, and then here we also end up with ln of the absolute value of u, and we have our plus c. Just make sure you plug in the correct u's back into the correct spot. So this u was x plus 1, and this u was x minus 2. And this is our final answer here. Alrighty, thank you.